Next, we are going to discuss about the test compressions. So previously we discussed about the how the compression can be done, what is compression, what are the types of compression, lossy compression and lossless compression, and we discussed about the source encoding. And then in that source encoding we have two types. One is nothing but the differential encoding method, another one is a transform encoding method. Then we have discussed previously about the entropy encoding. In that entropy encoding we have discussed about the run length coding and then variable length coding. And why we are going for the compression, these are all the things we have discussed in the previous class. Now we will go to the text compression. There are three different types of the text. One is nothing but formatted text, another one is a hypertext, another one is a unformatted text. Here these texts are represented as a string of characters which is selected from the defined set of characters. The string comprises or which consists of alphanumeric characters which are interpreted with the additional control characteristics. Different types of text use and interpret the latter in different ways. The compression algorithm which is associated with the text must be lossless. That is very important. So text compression in the sense, whenever you are going for the compressing the text should be reconstructed in the destination or in the receiver part. That means it should be a lossless compression. Because suppose I am sending the word like Sairam College of Engineering. Okay, while you are compressing that time, some part of the signal is corrupted and that can be removed from the by the filter in the destination part, like a and m is removed. Okay, or a and l is removed, in the sense wherever the a will be represented in Sairam College of Engineering, that will be removed, and wherever the L will be represented in the Sairam College of Engineering, the string, that L will be removed. Then we cannot be able to reconstruct it. If you reconstruct also, the word will give the meaningless. So that compression algorithm always which is associated with the text must be a lossless. If it is an image or audio also it should be lossless. Video in the sense, then image and video may be considered for the lossy compression without degrading the original quality. Okay, so compression algorithms which is associated with the text must be lossless. So for the above reason we use entropy encoding or statistical encoding methods for the lossless compression techniques. There are two types of statistical encoding methods which are used for the text compressions. One is nothing but use of single character at the basis, deriving an optimum set of code words. For example, in the sense we can talk about the Huffman coding and arithmetic coding algorithms. If you are using the variable length string of the characters, then it is called as LZ algorithm, that is Lampl-Ziv algorithm. There are two types of coding algorithms are used in the statics encoding. One is nothing but using single character base. Even every single character will be analyzed and that can be predicted and that can be sent as a compressed form of information, in the sense then that particular code words are called as the coding algorithm which is used for the particular process is called as Huffman algorithm, and arithmetic coding algorithms, or two algorithms are used for the single character basing code words. If it is variable length of the string of the characters, in the sense Lampl-Ziv algorithm, that is LZ algorithm is used. There are two types of codings are used with the text. There are two types of the coding is used with the text. One is nothing but static coding, another one is nothing but adaptive coding, or otherwise it is called as a dynamic coding. Either it is called as a static coding or dynamic coding. So static coding and dynamic coding, or it is also called as dynamic coding is also called as adaptive coding. So static coding, it is intended for application in which the text to be compressed as known characteristics in terms of characters used in their relative frequency of occurrence. Suppose A, B, B, C, C, in the sense how many times A will be occurred, how many times C will be occurred, how many times D will be occurred. That is coming under the static coding. Okay, and using above an optimum set of variable length codes instead of fixed length codes, it is derived for the shortest code word which is used to have more frequently occurring characteristics, resulting the set of code words then used for all the subsequent transfers involving this type of text. Dynamic coding, in the sense, it is adaptive coding intended for general application type of text transferring may vary from one transfer to the another transfer. In this case, optimum set of code words are likely to vary from one transfer to the another transfer. So the code words set which is used to transfer the particular text string is derived from the transfer takes place. This can be done by building the knowledge of both characters that are present in the text and their relative frequency of occurrence. So dynamically, as the characters should be being transmitted. The code words used change as the transfer takes place in such a way that the receiver is able to dynamically compute the same set of code words that are being used at each pointer during the transfer. So here we are going with the static Huffman coding. Okay, in static Huffman coding, the character strings which is going to be transmitted is first analyzed for the character types and their relative frequency will be determined. That means A, B, B, C, C, D, D, E, E, F, F, in the sense up to 64 or 128 words, in the sense how many times A will be present in the 64 bit length. Okay, how many times the B will be set, how many times C will be set, based upon the characters of the string to be transmitted is first analyzed. The coding operation involves creating the unbalanced tree with some branches shorter than the other branches. The degree of imbalance is a function of relative frequency of occurrence of the characters. Larger the spread, more unbalanced. If the spread is more, then what will happen? The tree is having many branches. If the unbalanced thing will be more. Okay, so larger spread will cause the unbalancing of the tree, so resulting that the tree is obtained from the above mentioned process. We call it as Huffman coding tree. Okay, Huffman coding tree, in the sense, it is a binary tree with the branches assigned the value from 0 of 1. Base of the tree is normally geometric. Top in practice is known as root node or root of the particular node, and the point at which the branch is dividing is called as branch node, and the leaf node is nothing but the termination point of a branch for which the symbol is being encoded for the assigned values. And